the standard enthalpy of formation of a substance is equal to the heat that is released or consumed when 1 mole of the substance is formed from its elements in their standard states. For example, the standard state of oxygen is O2 in the gaseous state, and hydrogen is H2 in the gaseous state. When 1 mole of water is formed from 1 mole of hydrogen gas and half a mole of O2 gas, 286 kilojoules of heat are released. It is convenient to illustrate calculation of the heat effect of a reaction using the following diagram. The chemical system composed of half a mole of O2 and 1 mole of H2 becomes 286 kilojoules more stable when these elements combine to form 1 mole of water. Among the two compounds, the one that is thermodynamically more stable has a more negative standard enthalpy of formation, and vice versa. Hydrogen peroxide is another compound made of hydrogen and oxygen. The standard enthalpy of formation of hydrogen peroxide is -191 kilojoules per mole. It is less negative than the standard enthalpy of formation of water. Therefore, hydrogen peroxide is thermodynamically less stable compared to water. There are substances whose standard enthalpy of formation is positive. For example, the formation of 1 mole of hydrazine gas from 1 mole of nitrogen gas and 2 moles of hydrogen gas requires an input of 95 kilojoules of energy. Therefore, hydrazine is thermodynamically less stable than its constituent elements, hydrogen and nitrogen. In other words, 95 kilojoules of energy is stored in 1 mole of hydrazine gas. This energy is released when 1 mole of hydrazine decomposes into its elements. The heat effect of a chemical reaction, delta H, is defined as the difference between the sum of the enthalpies of formation of the products and the reactants. This implies that chemists can influence the magnitude of delta H by using specific substances as reactants, and designing reactions in which specific substances are formed as products. The formation of products that are thermodynamically stable compounds, such as carbon dioxide and water, lowers the delta H of the reaction. Reactants, elements in their standard states, such as O2, do not make delta H more positive. Reactants, compounds with positive enthalpy of formation, such as acetylene, C2H2, contribute to a more negative delta H by lifting the energy of the chemical system. These aspects of selecting chemicals as reactants and products are illustrated by the following examples. Consider the reduction of copper oxide to metallic copper by 2 reducing agents, hydrogen and hydrazine. The heat effect of the first reaction is -86 kilojoules. The standard enthalpy of formation of hydrogen gas and copper metal are both 0. Therefore, the heat effect of the reaction is defined by the difference between the enthalpy of formation of water and copper oxide. Considering that water is a thermodynamically more stable substance compared to copper oxide, this reaction is exothermic. The heat effect of the second reaction is -133 kilojoules. The reduction of copper oxide by hydrazine is more exothermic compared to the reduction with hydrogen. The reason is the positive enthalpy of formation of hydrazine, which partially compensates for the negative enthalpy of formation of copper oxide. The spontaneity of a chemical reaction is defined by the Gibbs free energy change, delta G. Among these two exothermic reactions, delta G is more negative in the reaction in which hydrazine in gas phase is used as the reductant. This is mainly because of the more negative delta H value. In ChemChallenge, there are 9 chemicals with positive enthalpy of formation: acetylene, benzene, diamond, ethylene, hydrazine, nitric oxide, nitrous oxide, nitrogen dioxide, and ozone. Visit savativegroup.com and get your copy of the game and other educational materials.